Hi everyone, welcome to another episode of the Common Lisp Study Group. I'm your host, Ram Vedam with Atlanta Functional Programming. As you all know, Atlanta Functional Programming's mission is to promote functional programming as a dominant paradigm or primary paradigm for large-scale large-scale systems design and application development. We are a language-agnostic community that tries to adopt functional programming in many different languages. If you're interested in giving a talk, please let me know. I am Bugram on the functional programming Slack channel, as well as I am available as Bugram on the Lisp Discord server. Please post your talk topics, and I will get to them as soon as possible. Today, we will be discussing some limitations with the cells library, which we have been covering the last couple of weeks. Last week, we kind of picked up we completed our discussion of the cells library itself. We actually talked about specifically drifter cells, synapses, and kind of wrapped our little bow of an overview of the cells library in general, how one might end up using it in their applications. As you all know, cells itself is a library that's available to on QuickLisp already and provides you a way of designing reactive style applications. But there are some limitations to the library that we'll be discussing today, particularly some stuff related to its design, how one might end up adopting it in their own applications. We'll talk about maybe a couple of examples here, just so that we can cover kind of combining some of the concepts that we talked about the last couple of weeks, just to bring it together and sort of give you an understanding of what's going on. In addition, we will be discussing some alternatives to using the cells library, a couple of ones that I've been kind of playing around, one of which we've actually covered on this channel in our discussion on concurrency. We could use the same library to actually do a reactive style program, and we'll be talking about. I'll be posting all those our article. Those links in the GitHub description. Okay, let's get started. So, like I said, last time we talked about really the final pieces of the cells library and how it has these cells that allows you to essentially keep intermediate results, and being able to actually uh, take those intermediate results and be able to keep track of them in a very reactive manner by providing a formula that contains an initial value and a reduction function, which will take the next increment and continue to actually update the previous sum of the actual cell with a new value. And you can see this here in our example with drifters. if we go back to here in our drifter counter, we talked about how we could start with this initial value with the cells c dot 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 function, which will create an actual drifter cell, and we provide essentially a function that ultimately says, okay, from this initial value, the next function is going to be summed to this initial value, and we talked about how this expands into its own kind of hierarchy. So one thing to note about this particular thing here is we covered this last time. The drifter cell is mainly used to keep incremental results, and specifically the drifter counter here that you see here. This actually ends up making its own instance. They'll take the code that we provided, which is dealing with the current lambdas, and it will overwrite, in this case, the drifter cell with the current elements in that counter. And we saw an example of this when we talked through this project here, where if we quick load this guy, this ends up creating a drifter cell that up here, drifter, right here, our D counter. If we go up here, we just do D counter. We see that we have a drifter counter that if we just simply call a function, say for example, where is it? Our drifter example. Drifter. Okay. Here we go. If we pass in our drifter counter here to try counter, D counter, we end up with this example that essentially took the previous element and added the current length of the actual list being processed into the drifter counter itself, and we kept a reduction of all these lengths of each of the lists that we processed inside of this. We also talked about last week on how cells provides you not only eagerly evaluated cells that upon actual triggering of any change event, it will automatically compute the property, but we also have this notion of lazy cells that were rules that allows you to determine whether or not a particular cell is can be computed on demand with the type of with the type of once asked. We have lazy cells that we can have that can be either once asked, until asked, or always. Remember last time when we talked about once asked are those cells that upon initialization they will be evaluated immediately, and then they won't get evaluated until they were asked again. They will otherwise they will lazily just sit tight with whatever previously ruled cells that they could do. So you could change it as many times and the computation will never occur. Until asked, obviously, is also that it does not get evaluated or observed until the application code tries to read a particular cell, at which point it will try and compute it, where it's a complicated piece of code might cause a small pause, and then it will only reevaluate at that first point. After that, obviously, it becomes an eagerly evaluated cell, which means as soon as any change propagation event occurs, the lazy cell itself will keep computing itself. And then if you want an always lazy cell, obviously you just need to say that it's going to be of type always. And we had an example of this in the previous episodes where we actually took a lazy cell and we provided this question mark underscore question mark cell, and we had this example where we had 5 cells here that provided us whether or not we are dealing with once asked, which is our first case here. Obviously, in our second case, this is until asked, and then our third case is always here, as it's going to be determined here. And we showed you the 2 different ways of actually creating lazy cells. The first, obviously, we have these macros, and we also showed you that we have the C formula that's available. That will give you the initial cases related to it. And finally, we also talked about, when we were dealing with synapses, we talked about how to create a synapse, which is kind of like a semantic network where change propagation occurs only when a particular condition is met. And once that condition is met, which for folks who are coming in from the neural network world, or for folks who understand synapses, it is kind of like a threshold function, usually some sort of sigmoidal kind of like triggering mechanism. That is what ends up causing the actual chain propagation events to actually occur. And this is through the F sensitivity macro, where we can specify the name of a synapse and then some sort of initial condition here, which is actually the condition upon which the threshold is checked on. So in this case, we have this example where the synapse is actually waiting on the wait time of the cell, and based on the wait time of the cell, it will go and trigger the condition to compute the current time of the cell, and there is a delay between the current time and the time elapse. We also saw that this can be determined also with us naming our own synapses by using the cells with synapse keyword, where we could specify some code that will determine whether the predicate that we want it to trigger on, and what should happen when it's true, and what should happen when it's false in terms of propagation and not propagating. Now, one of the things to note about this library that is it's a limitation for some folks, but it is something to be aware of. Cells is very, very slot oriented. Okay, it is almost completely built on top of the common Lisp object system, which means to really leverage cells inside reactive code, you have to actually go and end up having to write and use the common Lisp object-oriented extensions using the common Lisp object system, and define your models using and creating instances using class objects. At which point you then get the slot machinery and the reactive extensions for free. There are alternatives to this sort of style of programming, of course. And but when it comes to reactive, there's the space is fairly large as to how you want to design reactive systems anyway. The one thing to be aware of when you're designing your applications with, say, cells is, again, when you are dealing with actually the reactive extensions, you are dealing with the dealing with objects and methods associated on those objects. Okay, and I will show you in a little bit of where we might be able to use some alternatives to actually go and touch base on that. To really drive home a lot of this stuff, we've come up with several examples here that I will post on the Atlanta FP repo. But the examples here are all somewhat contrived in terms of real-world models. Is mainly because of the fact that I wanted to illustrate the particular concepts that that each of the concepts represent. And Stefano also did a very good job with some of these that I just referenced here. That I don't think we need to to go through and display. Sorry. Okay. So very quickly, I thought we would just first come up with one final example that covers almost everything that we talked about. For some reason, okay. So, for example, and in here, we're going to be just, it will combine some of the concepts that we talked about here. That is the lazy evaluated cells, the eagerly evaluated cells, and the drifter cells. Okay, where it's necessary, where it's not necessary, and so forth. This is going to be a simple, application. Obviously, the easiest way to probably start this off is probably start a new project. Let's say that we're going to create the back end for a ToDo application. Okay, this is kind of a very simple application that could be used to actually determine some stuff. Okay, so first, let's go ahead and create our ToDo application project. Okay. By calling cl project, make project. Local projects, AFP cells, example. Let's in fact just call this ToDo app to make things simple. And we're going to go ahead and in here specify our dependencies. Specifically, it depends on, we're going to use Alexandria, and we're going to use cells, obviously, and is there anything else we'd want to use? Probably not. Okay. So the first thing that we're going to do is we're going to create a simple test case. Okay, I like starting to write some tests associated with kind of what we're expecting. So this way, it's easier for us to actually go in and just write out kind of how the reactive model should occur, and we can test out some of the simple just these simple workflows. And this way, when we're building up our model, as we're testing our equations, we have some tests that can actually be run behind the scenes just to make sure things are okay. All right, so let's go ahead and open up our ToDo app. Okay, and we're going to go ahead and open up the test main test. Hold on 1 second. Roswell project to do one second. This looks wrong. Oh, no. Sorry. Let me go and look at one thing. I think I may have had a to-do app in there and I just inadvertently did something. Okay. Let me try this again. Okay. For some reason I had a to-do app in there that just kind of got messed up, so that's why I did it. Okay, so let's go to our to-do app, our tests, and our main.lisp. Okay. So now, as many of you know, we're using Rove, which is the successor to Prove. It is a testing library that's already built into CL project, which is created by Fukamachi. I've discussed Fukamachi's project several times on this stream. Please look at our past discussions about this to kind of understand what's going on here. So what we're going to first do is we're going to first comment out this test. I'm going to keep this as kind of like a template just in case. And what we're going to do is we're going to define, we're going to have to do one thing before we can start defining tests. We need to first stub out our API. So let's go ahead and open up our source main.lisp so we can actually also do that. And what we're going to do is we're going to go ahead and create a simple cells def model. All right. And what we'll do is make this a naive def model that will represent to-do list. Okay. So every to-do list will have, of course, a list of items. Okay. And we'll go ahead and make this an accessor so we can leverage actually doing a generalized expander on this to add items and such. So we'll do this, say to do items in the list, and we're going to make this an init form as being an empty list to start things off, just because it'll be it is a list that we will end up adding to. Okay, and let's do an init arg of items so that this way we can actually specify, a non-empty set of lists. Okay, here specifically, what we're going to do is we're going to make this into a cells cin and make this into an empty list. So this way, the list itself is going to be, when we add stuff into the list, they themselves are going to be initial cells that are going to change and update this list and trigger some additional things like whether or not the to-do list is done or not. Okay. And let's see, we got this. And what we're going to do is we're going to have a done, which is going to be, in this case, a reader. And its init form is going to be nil. Cells colon. It in this case is going to be the condition. In this condition is going to be telling us what we'd like the condition is to check to see if I don't know if there's an all. There's what should we do? We need to go in and okay, so this is going to be a little naive, but we can actually do this. We could start with let res be res be true. All right. And what this is going to be is so whether or not, let's see if I can do this. Let's res be true. Let's see if I can do that. What is type of key? Yeah. So we can start with res be t, just making sure that the capital T is the true, because I had lowercase t, I think if I remember correctly, is root of all objects. So we need to make sure that we use the right t here. And what we do is we just loop through 4 items in sorry, 4 item in items, to-do items, sorry, to-do items of cell actually I'm getting ahead of myself. Let's go ahead and make this guy getting ahead of myself. Let's go ahead for the time being, just make this guy null. Because what I'm writing already is the logic that we're going to be dealing with, and I'd rather not do with that right now. So we now, what this is now representing is the to-do list. We have a list of items, and we know whether or not the list is done or not, okay? And we might want some metadata here, just in case, like name, accessor, the to-do, the list title, okay. And its init form is going to be, actually, let's do this. The cell here is going to be nil. So now this is a not registered list that's going to trigger any sort of change event. And now we're going to also make this guy a empty string, and we'll have an arg name. Okay. So now we have a name for the to-do list that we get by calling the to-do list name. We have a list that are associated with the to-do list, and we check whether or not it is done. Simple stuff here. There is a couple of things that I am missing. Let's see here. Too few arguments in, blah, 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 blah. Okay. Oh, sorry. There we go. Now, did I miss anything here? I didn't think so. Macro expansion, too few elements in to-do list. Okay. 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 And just go ahead and change this here. This might be the case where I may have messed up. Let's do this just to keep things going. Okay, let's load our to-do app. And this is what I was kind of not expecting. 9. Okay, so there's an issue with cells def model, blah, 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 blah. Okay, hold on 1 second. Let's go in here and see what's going on here. Okay. It's, oh. Thank you. Okay. So we now have our list being done. I forgot that I have to name my reader. I guess that tends to happen sometimes. Okay, so we have our to-do list set up. Okay. Obviously now we can write a very quick test to-do list. But before we do that, let's also specify what a to-do list item is going to be. Okay. Now this is just basically going to be the name of the item, which we'll call to-do list item name, and obviously the init form of this guy is going to be a string, and this is going to be, this is not going to change anything, and we're going to go ahead and make this what's it, have a checkbox called, you know what, it's called, let's shorten this to TL item. And here we have TL item done. Okay, and we will go ahead and make this guy a cell CN, because obviously it's not going to depend on anything, and we're going to set it to false. Okay. All right. What did I do here? List item is unbound. Oh. Cells def model. Okay. So we now have cells, our to-do list item and our list item. So now we can write some very quick tests here. We'll open up here our our list here, and we're going to go ahead and quickly write a few tests here. So the first thing is we're going to check out these are tests for our to-do list item tests. Okay, I'm obviously for simplification keeping all the unit tests in the same file. You may want to do what you feel is the most appropriate for project organization yourselves. But for simplicity's sake, I'm putting all the unit tests here just so that I don't have to jump around between different buffers very quickly. And here we're just gonna go ahead and do a to-do list here. I'm gonna name it as a single def test to-do list items construction. Okay, just to name all the different kinds of tests that we're going to be dealing with. So the first one is obviously empty. Actually, go ahead and also do this. We should put a knit arg on to-do list item. Knit arg TL name. Okay, and let's go ahead and do that. And the default form for that is fine. Okay, so empty construction of to-do list item creates, you know what, might be easier to do this. Okay, and going to kill that buffer. I'm going to open up the test slash main. Okay. This guy is going to create item with empty name. And, that isn't done. So that is not done. And it's not done, as you're going to see in a second what it is. So we can see that we can use this macro to go ahead and create a couple things. So OK equals, so let's just do this first. Let instance be make instance of to-do list item. And we could do this because the fact that here we are in the namespace of we are using the namespace of the to-do app. And both of them are in the same namespace, so we don't actually have to specify the namespace inside, the package name prior to actually instantiating this guy. And so with this, we're going to go ahead and not specify any name. And we're going to go ahead and do OK, and make sure not null. Okay, we won't get a null in the instance. OK, TL item name in is going to be the empty string. And OK, TL not TL item done. Okay, so we have our first test. TL item descriptions unbound. Give me a second. Let me go look at what this is called, what it's doing here. It's because we did not load this test. Okay, let's go ahead and load this package. QL quick load. Okay. What is the name of this? I think it's called ToDo App/tests. ToDo App/tests. See. Okay. Sorry. NRS. So if we look at this, we can see that this is now defined. So this is all good. We need to first, obviously, define this guy here. And we see our first warning, actually, when we wrote this test, okay? Now, when you see this warning here, these undefined functions, what that really means is they haven't been exposed in the package. So what you're going to have to do is just first export the names of these functions. So let's go ahead and export them accordingly. TL item name, TL item done, and we're going to have to do the same thing with the other ones too as well, which is our accessors for the to-do list. Oops, sorry. Just realized that these are method names. Okay, let's see if this, sorry, let's do this. No, let's do that. Still not there. Right, that's because they're not exposed. So let's just go ahead and expose them. Okay. Done. Make TL item done accessible. Yes. That's the one that we want to do, and we want to also unintern the other one. So now defining this way, this is all good. Okay? Because we've now defined the def package. If you saw here, sorry, if you see here, if we go and define this now, everything's good. We need to do sort of the same thing with the other ones, but for the time being, let's go ahead and just, we're gonna just deal with the empty construction here just to make sure our tests are passing. So let's go ahead and run tests. If you remember, Rove has run test, it's one suite now. Let's just do run. Let's see if I can just do this. ToDo List items construction. Not lists. Sorry. Okay. So now we are getting somewhere. We are saying class is not found. There is no item name test main ToDo list item. Well, of course, it's not. So this means that we have not exposed the to-do list item out of the package. So we need to go ahead and fix that. We do to-do list item. Okay. Obviously, this is one of the beauties of doing this in Common Lisp. We have the ability to actually go in and unintern symbols in the running image. So this way we can actually intern the correct image. So it will correct the image as we're running. Remember, this is a running process, so symbols are automatically loaded into memory. These symbol objects keep track of themselves. By doing this uninterning and interning stuff, we're basically getting rid of incorrect symbols and correcting them. You could also shadow it, but I don't recommend you keeping the shadowed objects because that could create undefined behavior, which will force you to reboot your Lisp image. So this is kind of the approach I would take. I'll use the take new restart, which will allow me to go and update that. So now this is all good. Let's run this again. This is all good. And now if we go ahead and run this, we'll see that the test complete. Okay, so we now have our first test that is expecting the things to be false, and we see that it is false, and we see that it's going to be set to false. Okay, so now let's see what may happen. Let's try. And let's say not empty construction, it's default construction, given where it is here. So now we're going to add one more test to this test suite, if you will. We're going to be testing construction of item, item name, sets name of task. Okay. And in fact, I'm going to go ahead and at this point, things are coming together here. Instead of calling this to-do list item, I'm going to name this appropriately as a list of tasks to do. All right. So now this is now our task name and our task done. So this is another thing that you'll start seeing that would be useful. As you're starting to use your API and you're leveraging it, you might come up with better nomenclature. Updating the nomenclature accordingly will be very, very useful. So this way, it makes things more and more useful. So we have here. We're going to also make this tasks. So this way, and we have this, we have this, we have this. Let's go ahead and change this to task name and task done. And let's go ahead and change this into task. Now, the next thing that you may be wondering is, well, what about the symbol of the previously defined class? Because it's going to still be in memory when we do this, okay? We see this here, task here, and here. Okay, go ahead. Okay, we're good. Okay, this. Okay. Go to here. Installation 2 warnings. Hold on. Let's see something here. Warnings also exports with the. Okay, so we basically now kind of changed our image. So let me just quickly do this. We just go in and we start the image because it looks like I may have messed the image up by constantly switching and redefining these objects. Sometimes this can occur, but it's not. Let's start with ToDo app. Oh, sorry. And let's also include tests. Okay. And let's go ahead and run ToDo app tests. Tests not exist. Okay. Import. Let's see here. If I can get into this MRS. Let's see if this works. Okay. this here. Let's go down here. Class not found. Task. Okay. Warning condition. Let us unintern. Unintern. ToDo app. ToDo list item. Okay. Still doing what now? It's still saying that it exports. Okay. So I'm going to have to go and first change this for a second here. Give me this 1 second here. Okay. I think we're good. And yes, we are good. Okay, so we now fixed all these renames that I just did. Let's continue on. Let's go ahead and add. Okay. Let in make instance task with the name task. Finish this task. Okay. So now let's go ahead and actually make this into a let star to make it a little easier for me to actually go and oops. Okay. Name, task name, finish this task, and let's do this task name, and let's call this title to make it easier, not to confuse some folks. Actually, it shouldn't matter because it's a Lisp 2, so we should be okay. Okay, we have our things. So now we could just do, move this down. Okay. So now here we could just do okay, not null, and obviously we're going to always be checking that. Don't have to, but this is just, me being a little insane. Okay equals, and we're going to do a string equals. String 1 is the task name that we provided, and string 2 is the task name of the instance. Okay, we got this. Let's go ahead and run our tests. And you can see now we have an additional set of tests that are being written here. Now, you can totally write each of these into individual tests. I just prefer to keep them kind of constructed, associated with each of the individual specific things. All right. So now we can also have a test suite very quickly for task item done tests, where we try different ways of actually making sure the item gets hit accordingly. Now, one thing to note is since this is an input cell inside of a task, this won't really affect us in any way yet. But it's important to make this guy in the model an input cell, because later on, as you will see, it's going to be used to trigger a change propagation event at a higher level. So this is how you are going to build these kinds of trees of things associated with it. And to my folks who are just chiming in and joining us, feel free to ask questions at any point in time as I'm going through this, and I will answer them accordingly. So now let's go ahead and do it quickly. Can appropriately set done item done for a given task item. Okay, and in here, let's go ahead and do this. That in the make instance of the task with the name test item. Okay, we're going to do okay equals, again, this is okay, not task done. Again, this is just, another insane check. You don't have to always do this, but this is somewhat useful just to make sure that if someone decides to break the API at some point, some tests are defensively making sure that we're appropriately tested correctly and run. Now we could do set f task done in to true, and now say okay task done in. Okay. So now we have a test here that will just test to make sure we can appropriately set it. We go ahead and run our tests, and we see we have, oops, we're only running one of them. Let's go ahead and run the suite. Run suite. Hold on 1 second. Run suite. Suite name, I think, is what it is. Let me just go ahead and do a quick describe here, so I can make sure that I do this. Yeah, lambda list is the suite name. So let's see here. Rove run suite, and our suite is, if I remember correctly, the top level package is the suite. To run this test file, just execute and do that. Okay. Right, that's right. I forgot that we can also do this. Let's go ahead and do that, but let me first run this specific test, because this will also be useful to know. Task item done tests. Okay, so these are all good. And let's go ahead and now let's go ahead and run asdiff test system, and let's specify the system ToDo app, which will go ahead and run our test suite. And you can see that it ran all of our tests. Our tests are all passing, so now we can move on to the next item. The next item is going to be just dealing with the to-do list, and in the to-do list we need to essentially do a couple things. One is we need to first def test to-do list construction, and there's a couple things here that we're going to have to touch base on. One is related to the actually empty construction. The other one is also related to the what's it? Whether or not we can add items into the actual item and the actual tasks list. One thing to know about the task list is the task list is going to be an input cell, but it's an input cell of input cells. The reason is this nested list is necessary is because if we add to this list, and if any item changes, that change propagation should go up to the higher level. So that's why this input cell is there, or at least this is how I understood how these nested structures would work. A better approach might be to make this into a family, and we'll touch base on that in a moment. But first, let's see what this is all about. And by the way, if we make this into a family, this might simplify things. In fact, let's go back and see if we can make this quickly into a family. Because a family might be more appropriate for this. Now that I think about it, just because it is a nested structure here. So remember, that a nested family is nothing more than a subclass of cells family, and it contains cells themselves. So we don't have anything here. We don't have to change anything to actually do this family change that I was suggesting. This here can stay the same because of the fact that it's going to be slightly. It's not going to change anything. The one thing to know is, of course, we want. Well, let's first try the first one, and then we'll go through the second one. Okay, because I don't want to complicate things right now. So let's go ahead and do this. Sorry, let's see here. Let's do this. Okay, let's do this, and let's see what happens. If we need to change it into a family, we could change it into a family, because the family would simplify, honestly, the done, if anything, on how to compute the done value of our instance, because we're just applying essentially whether or not we're done on every other function that's available. So let's quickly create a couple of tests here. Empty list construction will create list with no name, empty list, and is a not done block. Okay, so let's do this quickly. Let in be make instance of our to-do list. Okay, and before we do that, let's go ahead and add our to-do list here. Let's add all the accessors for it, this name, tasks, and whether or not we're done. I think that's the remains. To-do list done. Okay. So we have our new exposed functions. Let's go ahead and update our test here. Okay, we have this. Obviously, okay, not, no. Okay, okay. String equals. Could use empty. No, there's no string. Down case. Yeah, string equals is probably better. This and to-do list name in, and then okay, string. Let's say I'm thinking scheme equals, and we'll take the to-do list. Let's say 0 to-do list items. Oh, sorry. Length of the to-do list items of the tasks of our thing. And of course, we want to make sure that it's not done. So not to-do list done. And okay, go ahead and run that. Okay, let's go ahead and run our list here. We now have our list to be true. So now let's go ahead and see by now you may be wondering why in my to-do list I have this guy set to an in function, because technically you can have an empty list or do whatever you want as a list in your application, and sometimes some folks want to be able to just simply mark off their to-do list even though none of the items are done. So they'll say done, we're going to go ahead and mark it off so that it gets reviewed. We want to be able to do the same thing, so we're going to go ahead and do that. And we're going to write a quick test for that. To-do list, done tests, testing, empty list can still be marked off as done. Here, and we'll do that in make instance to-do list. Okay, and we want to be able to make sure that it's not null, and we want to be making sure that it initially starts off again as not to-do list, not to-do list done. And we're going to set it. And now we're going to say to-do list done. And set. That's weird. undefined function to-do list. And we see that we just we did something, and that's because we made this into a reader, not an accessor. So we really need this to be an accessor. Simple fix. We recompile the model, recompile the test. Now everything's done. We run the test suite, and we have our test suite. Okay, so far so good. We now are able to run a test, create an empty list, mark it off as done if we wanted to, but we need to still be able to add tasks to it. Okay, but now we're getting to the brunt of our exercise. Okay, so let's go ahead and add. There's two cases here. One is let's say you have an empty list and you put in a item that was explicitly marked off as done. For example, you might be moving an item. Let's say that this could be used as like a Scrum dashboard, where you're moving an item that was done, but it's part of a larger task, and you're moving it into some larger task that contains a bunch of empty items. All right. Well, in the case that it's empty, if it's done, then the top level list should be done. All right. Especially if you're trying to create lists of lists. We're not going to talk about lists of lists in this example here, but you could certainly think of that in the single list case. If it's an empty list and you're adding it to be done, then the top level should trigger to be done. The other one is if you're putting it to be undone, and we already considered the task list to be done, then we need to make sure that it's false. Okay. We're going to touch base in both of these in the empty list case. If it's an undone item put into a list, then the list is undone. If it's a done item and it's put into an empty list, then the list is done, unless otherwise marked. All right. So this is the important distinction. We're going to deal with the first case here. All right. So to-do list done, tests, and you know what? We're going to go ahead and add this to our larger test suite because we are manipulating the tests here. Adding done item to T-list marks the list to be done. Okay, so we do this, and let me just make sure that I have an init arg on this. No, I don't. Let me go ahead and make this an init arg to do task done. Let me just make this into task name too. I know. I'm kind of screwing with a bunch of things here. Oops, sorry. Make this to-do list name. Task name for consistency's sake. Okay. Okay, let's go ahead and change. Okay, I have not dealt with the other case here. Let me go ahead and add this quickly, which is testing name list construction will create list with the appropriate name. Okay. Okay, let and make instance of to-do list task name. Sorry. To-do list name. So now we could do this. Create make instance to-do list. That's the list. And again, I should have really made this into list name. Okay. Let's start. Set up list name. Okay. And here. And we do okay. Okay. To-do list done. Okay. Hey, oops, wrong test. Just realized that I'm writing this in the wrong for the test. Go ahead and run this here. That's fine. Here we go. Okay, now we do okay, no in, okay, not to do list done. Okay, and we got one more, which is the actual string equals, being list name, to do list name, being and let's go ahead and look at this one specifically by running tests on to-do list construction. Okay, so we have our tests all passing. Now, let's go ahead and talk about this one. So now here we have our make instance on some to-do list with some to-do list name of let's say test list. Now, some of you may be wondering, why are you naming your init args to-do list name and to-do list this? Normally, what I would do is when I create objects and class, I would also create a constructor function, like a Lisp function, like a defun. But for making things simple, I went ahead and did this. But certainly, you could do something like this, where you had your to-do list, and then you also create a defun make to-do list, and then make these all keyword arguments. Okay. In fact, a lot of folks, this is kind of standard practice. They expect you to kind of like do this, just so that it makes things a little bit easier to actually isolate folks from actually manipulating the init arg lists inside of a make instance. So you're making your API very explicit. And then you can hide a lot of the init arg stuff behind the scenes, and you don't have to expose them. Of course, they are publicly available because once you make a keyword, they are in the keyword space. Once you import them, but this is something that I've seen in a lot of APIs where they create a function that will explicitly create like a factory method to create instances, and then in this case we just do to-do list, and then we specify to-do list name, name, to-do list done. Done, and items to being items. And here we can also keyword arguments. You can also put them with defaults, so that this is like this, and this is well. Let's do that. And let's see if I can do this here. Instead of doing this, let's do make to-do list test list name. And we get, oops, let's do this, make to-do list here. And we just went ahead and did that. Go ahead and do that. We're good. This, and now our odd number of keyword arguments. Right, I keep forgetting. So here we're going to have two. That's right, you can't use default names for keyword arguments. What did you do this one? Default arguments on Lisp. That should be okay, actually. Because, oh, let's go ahead and make this all keywords. There we go. This will work. Let's see here. Make to-do list. Test. And odd number of keyword arguments. What? Oh, shoot. Sorry. So sorry. I just realized something. This is not what the problem is. This is the problem. My call is the problem. I am so dumb. Where are you? Name. There we go. This now works. Name test. This works, as you can see. Right. Invalid initialization argument to done. For some reason, that looks kind of weird. Let's see, Invalid argument to-do list done. Oh, right. That's because this needs to be a cell cn nil, and this here, because these are both cells, this needs to be a cells cn empty list. Okay. See this. Oh, shoot, that's right. We did not fix this guy to allow me to initialize this to have its own access. Net arg to-do list done. Because we needed that for the later on. We need that for later on for some of these other tasks that we're writing. Okay, there we go. And as you can see here, we got our list here being nil, and we got that guy. And of course, we have this too as well. Let's just go ahead and look at this here. And let's go run our as if things, and everything seems to be okay. All the 4 tests have passed. All right. So we have our to-do list. We have our factory method. We have our basic construction all working. We have our name construction all working. We have our. So now let's go and check to see if we can do this one here. Sorry. Go ahead and say make to-do list here. Now that we have the whole thing all set up. Test list. We do not need anything set up right now for the time being. Let's go ahead and first check to make sure that we are not done. And hold on. Let's go ahead and first create also an item. Just like this, I'm going to go ahead and quickly create a make task function. Define make task key name and done default is just set to this cell cn nil. Okay. Now we can just do make instance task name and task done. So we have that. Let's go ahead in our to-do list, our task tests. Call this actually task construction. Okay. One second. There seems to be an issue. What is the issue? Warning. Item is defined but never used. No, that's not it. Error. Hold on. Okay, let's do this again. Okay, nothing's wrong here. Nothing is wrong here. Nothing's wrong here. Oh, this one. Make task hold on. Make task is also going to be here. Okay. Now here we have our name being task, and we are done with this guy. Okay, and we are going to go and set this guy to be not done for the time being. Oops, sorry. Okay, we have now created something here. Oh, right, that's fine for the time being. We don't need to worry about that one just yet. Okay, all the tests are passing. Let's go ahead and add the item here. Okay, sorry. I think I would have to do a push into the list. And the push, I think push actually creates a, let me just double check this, push on empty list. Place one on an empty list, sorry. Push one on an empty list. Let LST be nil. Let me see if this works. Push one LST. Okay, so I'm going to have to make this guy nil instead of the empty list because that's creating a immutable list. Okay, that's not a big deal. Right here, change this to be that. Okay. Okay, good. Just making sure that this is all good. Now, okay. So we're going to be pushing this at the top just mainly because we're not going to be dealing with a vector of items for the time being. So let's go ahead and push our item onto our to-do list. Let's see something here. In this example, it's returning 1. Let's do a prog-n on this guy. LST. Good. So the difference between, remember, push new and push are two different things, okay? So push item into the tasks of the next. Okay. Dang it. Okay. Move this. Now that we push the item in the list, we know that this should be non-empty. So let's go and first check greater than 0, length of tasks is now 1, but it's greater than 0, it doesn't matter. It's not empty. And actually, hold on a second. There has to be I thought there was an empty P here. Must be crazy or something. Okay. I must be really thinking. I'm thinking scheme right now. Okay. So now we have a non-empty list. Let's go ahead and go and check to see if we are done. Okay, so let's see. we have one failed test, and that is our list to do test. And this is, we expected this to do. Okay, so how do we get this to work? How do we get this to pass? Well, what we want is essentially this to be a conditional cell. Okay, what is the condition? The condition is the default value is going to be yes, if it's empty, it's going to be empty. It's going to be false. But otherwise, it should be the and of all the tasks to see whether they're done, right? If you think about what a task list is you're done if all your tasks are done. What is all? All is you're a huge and on the predicates as to whether or not each of the individual items are done. So the easiest way to do this is to do, let's see, probably a quick reduction. The function is going to be and. The sequence is going to be tasks on cells itself. The initial value is t. And can't be and. It should be, yeah, it'll be true and this. Yeah, I think we could do this. So to test this, we could just quickly write a reduction here on and. Let's say we have the list true, 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 true. Simple example. And we have initial value set to true. Let's see what happens here. Is a macro, not a function. Okay, so I'm going to have to write a function that actually handles this. Okay. So let's go ahead, and since this is not a this is a macro, not a function, we are going to write a quick lambda x, y, and x and y. Let's go ahead and test this guy here on our reduction. Oops, sorry, not here. On our reduction, t, initial value t. If we go in and change any of these to a false, let's say it's a nil. Oops, sorry. We get nil. So we now have a very quick reduction here. We go ahead and do that, and we have our lambda, our list, and our initial value. Okay. The idea is anytime the list changes, this should trigger this event, and the only way it's going to so the one thing to note is for folks coming in from the practical common Lisp world, I am not using the hash quote, which is most people have become accustomed to using to represent a pointer to the lambda, because it's not necessary. You could certainly do that if you want that visual cue that this is a function pointer that's taking an anonymous function. It could certainly be a function name or so forth. And honestly, but when you're dealing with lambdas like this, you could just certainly pass in the function. When you're passing in names, though, I think hash quote is necessary. I don't think you can outside of, I think you could have to call something called symbol function to actually go in and get that, if you remember some of the basic stuff on that. But it's not necessary for this particular case. So we're going to go ahead and use that this way. So let's see if this changes our tests. Okay. And now we broke 2 tests in this process by doing this. What did I change? Empty list. Ton. Okay. Let's see here. So since it's empty, the initial value is true. If you want it to be not done, if we start with nil, we're going to have to change we're going to have to change the representation of the reduction. So we're going to negate here, but if we need to negate, we're going to do, it's not just simply an or. If it's a negation, it's not done. This is going to be, let's do this, and nil. It's going to initial value be nil, and then see, we can't use a drifter cell for this, otherwise, well, we could, maybe. It starts off with nil, and then, no, it's not going to change that. We can use a simple cage here. Well, there might be a way of doing it with drifters, but give me just a moment here. This one is going to be, if we want it to be not done initially, unless they've explicitly tagged it to be done. And then let's see here. What can we do to fix this? We could use a def observer to do this. It would be a little ugly, but we could certainly do that. If old value bound p, really don't like that idea though, just because I'd like to use a condition of, let's see, we could certainly do, got it. We'll keep this here. This is a little disgusting, but this will work. So if it's empty, so self, then it's nil. Otherwise, it's the result of all these conditions. Okay? Now this will work. Please. Now we have if greater than 0. Oh, I put I inverted the logic in that to-do list done test. Okay, so let me go and change that. This is there we go. So this we do that. We have now test failures. That should not be a test failure. Give me a second here. What is it? Let's go and run this specific test first. Let's run the construction test first, and then we'll fix I think the other one's a pretty simple fix. Run test. What is this one complaining about? To-do list construction. It's complaining about nil is not of type number. Oh, sorry. If not tasks cells self. Okay, that should fix that error. Okay, we fixed that one. Let's see if we can fix the other one. To-do list done tests. Let's see that. Okay, so now this one says expect the to-do list done to be true, but it is not done. Okay, so when we trigger this, okay, that should tell me this change here of pushing the list should have triggered this second list, but it's not, doesn't seem to be triggering it. So, easy test. We're going to write an observer on top of def observer on the slot name tasks. Sorry, on the accessor tasks. And remember, we need to specify the self as being our to-do list, new value, old value bound P. All right. Now here, for the time being, we're going to declare old value. We're going to declare and ignore old value and old value bound P for the time being. All right. We're only going to deal with the self and the new value. So now what we're going to do is we're going to check to see print when new value print adding new value to the list from then to the let's see if I think if we do a def observer, we can now look at, I think, the to-do list, sorry, task of self, and the item should be added, but let me see, task is unbound, sorry. Oh, sorry, cells, okay. Let's see what happens when we run this. Okay, let's start with, let's do a simple example here. Def parameter list. I'm going to do a make instance, sorry, make to-do list. Okay, name test list. Okay, so now we have a list, and let's go ahead and let's push new make to do make task name test item, and done is true. Task. Yeah. And let's push this guy into our list. What should happen? So we now have in our list two lists. That's 3. That's 4. Why is it? Okay, so the first one looks like it's a dotted pair, but that seems incorrect. Why is it a dotted pair? Let me first go and look at this guy. Now let's go and look at tasks on this right now. There's nothing. So if I add to it, go look at this list. Oh, right. I'm being dumb. Okay, got it. Okay. Do this again. Now when we're pushing, should have named it slightly different as an item, as a to-do list. Yeah, actually, let me do that. To-do list example. Boom. Now we are pushing onto the tasks of the item. Okay. So now, when we do that, we are seeing that it is not actually triggering the def observer, which means the item itself is not triggering any sort of change event inside of the model, which is why we are seeing what we're seeing. So let's see why we are getting that in our model. So tasks has a cell input set to nil. Let's blindly do this just like this. Okay. Just to see what happens. So we go ahead and create that, push it. Sorry, we create that, and push onto ToDo List, and we don't even get a triggering event. Let us see what happens if we do set f tasks ToDo List with the results of making a to-do list item like this. Because if this works, then we have a way of actually mimicking what we need to do, but we're going to be creating a new list every time, which is a little inefficient. We'll go and take a look at that as being one of the limitations, if that is the case. Test item, done true. Let's see what happens. Aha! It is not actually triggering it at all. That is weird. I wonder if the problem is the fact that I'm hiding, shouldn't be, but you know, let's see. Make instance to-do list, to-do app, to-do list. Might be that I'm hiding, no, I'm not hiding that, okay. And let's do task, sorry, to-do list name task list. Let's see what happens here, and let's see what happens when I create a list here. Interesting. So if I do tasks to-do list right now, we will see that it is there. But it did not trigger any sort of change event here, which is kind of weird. Let's see here. We got the majority of our application done, our test application. There's a few other things. I mean, we're done with the basics of our model, other than this remaining issue, and then we can tie it in. You can see probably through. Let me go back to the example list that we have here with our examples. We did unchanged if, we had a reader on the cells. simple cell 2. We def modeled it. We created cell 1, cell 3, so forth. Okay, just 1 second here. So let's see what's going on here. We have our in here we have, sorry, this one. Let me go ahead and close off our test just for a second here. And let's go and look at, so this is our old thing. Let's go ahead and split this and put our, no, not this one, our new one, just to see what the difference is. Okay. So we're using accessor, we're using init form, we're using cell cin. See, I'm just double checking to make sure I didn't miss anything here. We did init args. But init arg is fine. That shouldn't actually cause any issue. We used init arg here. In our example. It looks like we're going to be forced to using family in order for us to actually leverage what this is, which is a bit disappointing, but okay, that's fine. I kind of figured that this was the case when I started off with this example, but I wasn't sure when I did it. So if we're going to do a family, we're going to actually have to change up a little things, all right? So the first thing is we're going to have to do this to be cells family, not a big deal. We have our model staying the same. We have our name staying the same. We have our items being our family check. And then honestly, we're going to have this test here being also the check that I was kind of setting at here too as well. So there is kind of an issue. Let's see. Well, actually, I'll take that back. Let's see if I could do this as hoping that I wouldn't have to use a family just because adding families tends to be a little bit more, it's going to complicate things because it's implying that there's a nested structure. Really, we're having a flattened structure. We're just doing some changes. Let me do one more test here, just to make sure that I'm not screwing things up. Go back to, no, sorry, this main.lisp, come here. Let's start with this one simple example. I'm just going to double check that to make sure the machinery is properly provided. Okay, and let's see here. let's see here. Okay. Oh. Okay. This. Is greater than 5, right? So we're going to keep on changing and get triggers. Okay? So the machinery seems to be okay here. So what is going on in this particular case? Okay. Okay, this is all working. Okay. Let's see what happens if I do this. Okay. To-do list is our to-do list. You can see it's a standard class. We have all our cell stuff hooked up. And now, let's see here. If I try to add push item make task name test task and done true to the tasks of the to-do list, you'll see that it's been added, tasks of the to-do list. But for some reason, the tasks of the to-do list is not updating the actual cell. So, why is that? Maybe it's because there might be a correlation between the name of a slot and the name of the accessor. Let me see. That would be pretty stupid if that's the case, but we'll see. And obviously, if that's the case, then this cannot be tasks, this has to be items. Go ahead and we're going to have to go and restart our Lisp image to clear everything up. It's going to go and recreate it. Then we're going to go ahead and load up our to-do app. Okay. And then let's go ahead and do this. And let's see something. As if test system to-do app. Let's see what happens. Our test actually worked once we did that. Items, to undefined function. So we're going to have to break something here. Our tasks. Okay, so we need to go here. Items. Okay. This. Let's see what happens. Okay, so we're back into what we were talking about. Okay, so what is, let's start with row, run test on the list construction. What is going on? Ooh, sorry. Let's see, to-do list construction. Okay, so I'm going to have to first change this. Start that. Good. And undefined. Ah, I see. Didn't update itself correctly. Let's see. Can I do? Yeah, I can do this. On intern, to-do list construction. Oops, not you, intern. On intern. On intern. Okay. Now let's see here. And it's still going to be talking about, yeah, okay. Let's just go ahead and restart one more time. Okay, and let's go ahead and reload. And let's go ahead and run as a to-do app. And what is the issue here? Into this can be marked off. Oh, got it. It's in the other function. It's in this guy. I'm using tasks here. Items. Alright, so now we got that done, and what is adding a new value to be true? And it is okay. Let's go back to our test suite. And they said items in length is false. Why is that false? Let's go and look at what it's showing. Here we go. No, not this one. Here we go. To-do list add an item to be done. Expect to. Okay, the one that it's not done is the to-do list item. And that's because it did not get triggered. Okay. Oops. That. And let's see here. All right, so we have items, we have this to-do list, and let's see something. Let me try doing something else. Make instance, to-do app, to-do list, to-do list name, test. Okay. Okay, so, aha. Okay, so now, if I change this, so the problem is with my factory method, it looks like. Let me do this with that parameter here. Quickly to do list on that. So now we have that enabled. And now let's do a push a tasks, items on to-do list. And items on to-do list is not defined. Right, my apologies. To-do app items is set to nil. Okay. Now here, if we go in and create a new instance, because the problem is we need to register this instance. We're going to have to do push make the same thing with to-do app item with tasks. Okay, with task name to being test and task done to being true. Okay, so what is to-do list done now? To-do list done is not defined. What? Wait a second. Oh, right. My apologies. You got to remember that everything is now exported. To-do app, to-do list done is true. Let's see. To-do app, to-do list done is to-do app, task, whatever. Okay, so there's a bug here. And that bug is yes, here's our problem. Our problem is we need to make sure that both anding is going to be triggered. So let's say, what is it called? What is the to-do list, the task done accessor, task done X, task done Y. Okay, so now we now know what the issue is. The issue is that the factory method doesn't see a pattern that's normally associated with common Lisp methods, and you can see this quite a bit. It doesn't seem to jive well with cells, at least, it looks like. When you try to do a set F and create a new cell and register that into the model, it does not work well. It may very well could be that if you're going to do that, you're going to have to do a cells reset, but I mean, that's kind of screwy in my opinion. That's one thing we could try. Let's see something here. Let's do. But I didn't believe that you should be able to. You need to do a cells reset. Okay. Let's do a make instance one more time with our function here. Okay, looks like it's working now. And let's see here. Let's see if we could do this with our to-do list items. And to-do list done is, so now let's go back to our test here. In Lisp 2, we have our items test done. Okay, so let's go ahead and do nothing here. Let's do additive test system to-do app. Okay, so to-do app done is still not causing an issue. And if we look at the example that we came up with, let's do this. Now let's do to-do list done, and you see that it's still nil. Why is that? Well, let's see. Let's go into to-do list. Let's create this. Nil. And let's go back to what we had before, because honestly, items, these should be tasks. I know I've changed this multiple times through this discussion. I'll keep this for the remainder of this thing. Really, this should be named tasks, but we're not gonna. I'm gonna fix the issues here first before we get on to. Okay, so to-do list done is still being set. Let's go and check to see if the change propagation occurs into, because we observe that we're adding an item to this list. Okay. Let's go ahead and check cells def observer on the rule. Oh, I don't need to even do that. Do this. Control F, sorry, Control star. We're going to put this little prog in. We're going to first say print condition triggered. And this now should be updating itself accordingly. Okay. Let's go ahead and update this. And we see that, oops. So, task done, item cell self. If items cell self is not triggering that, what would cause this to be triggered? Let me go and look into the macro expansion of this guy. Okay, code is the triggering, the reduction. We did an and on the tasks. We checked to make sure. And we did a cell lambda. And a cell lambda is basically the rule that actually checks how this is converted, and it creates essentially a slot lambda behind the scenes that checks all these cache stuff, make sure that it's all accordingly fit. But what exactly would cause the trigger to it not? not occur. Let me see if I can do this. This should work. And the looks of it, we'll convert it. Let's see. Let me see if I can get this to cells, def observer, to-do list, done, self, to-do list, new value, old value, bound p, declare, ignore the other three. Old value bound p for right now. Actually, if when old value bound p print format t old value tilde a percent old value. Otherwise, format this format t new value a new value. This is just some debugging, and this is how you would debug the system to see if events get triggered into it. You'd add observers to this to actually go in and figure out what might be happening. So we start with this, new value is nil. You can see clearly the first time we construct it, everything is kosher. Okay. And we created this accordingly in cells cn. There it is. That's the problem. We cannot do that. We need to set this to nil. Okay. This should now work. Let's go back to our as if. Okay, we're still not quite there yet. Let's see, because we disconnected. What happened is we disconnected the items. Remember, when we're able to actually do this, once we instantiate, we can actually go ahead and use normal accessors to actually go and set everything up. So we can actually do this. And if we add a task into it, bam, we're getting a signal. Items of to-do cannot be set up because it is not mediated by a cell with input t. To achieve this, the initial value 2 equals arg should be wrapped in either a cin or a c input. Okay, so we're going to have to go and change one thing here, which is this. Cells cin has to be null here, but not the other one. Let's see what happens. Okay, so far so good. See this, CWI C stop. CWI C stop. It's I may have to do a cells reset again. Okay, let's do this. Okay, got that. To-do list done. To-do app. Okay. That is wrong still. So what is going on? Okay, so this guy here. Okay, so we lost. So we cannot set this guy up at all. So we need to lose this guy completely. Where is unit dart? So we cannot actually set the way we want it set after it gets initialized. So we need to do this. Okay, this is going to change our one of our test cases. Yeah, this one. This one needs to be removed because we can't mark it off done explicitly. Actually, we can. Actually, I take that back. We can mark it off done. It's that we can't actually. We can't explicitly call it. That's all. Which kind of sucks, but that's okay. That sometimes happens. All right. Let's start this. Yeah. Oh, sorry. Let's do this. Oops. Cells. Reset. What is going on here? No initialized argument for to-do list done. Got it. Okay. So now, let's go look at the tasks. Condition triggered, but called with arguments. There is no. Got it. The first time that we do this, unfortunately, we got to change this because we can no longer use a reduction because we're expecting the initial value to being a cell object. Sorry, not a cell object. Yeah, a task object. So in this case, we're going to have to do something slightly more different. We're going to actually have to first do the following. X and Y stays the same in our reduction. Here, we're going to do a map car. Sorry, let me change a couple of these. Here, X, Y, good. Still compile. Here, wrap it, map car, task done on every item. Okay. So now we're grabbing all the tasks done, creating a list, and then reducing them. Okay. So now let's do this. we're going to have to create a new instance of this. We're going to have to create a new instance of that. And now we have this. Okay, so let's see what happens when we run our tests. First, let's do a reset. And we run our tests. And we see all of our tests pass. Okay, so we now are able to actually go in and add a done item. We're actually able to, so technically this is okay. So this can be cleared up, moved, taken out. Oops. No, sorry. That's right. There we go. So now we can do that one more time. Everything is golden. We got our pass. We can now finish off our test suite, and I think we're done for our model. And we've tested the model. We've actually debugged it. You could see that we've gone through and actually debugged this. We tested it up, we checked it out. We tried different things, of course, to actually go in and make sure that the actual model is consistent. And we went ahead and even made ourselves a little. We realized that we didn't have to actually use the family to actually go and do this one. All right, so let's go ahead and finish off our test suite. Make sure that we don't need to add any additional function pieces of code, but for completion's sake, honestly, I think we've essentially covered everything here, but we will see. Let's go back to this. So we know that this is true. We're going to have to go and do the opposite to verify that is also true. So we paste it, adding unfinished item to an empty. We'll mark the list. Does not mark the list to be done. Now, one of the nice things about this test suite is you're getting these very nice, expectations for each of these tests. So do this, get rid of that, we add this, and we still are not done. Now, let's make sure that this is registering, because sometimes it looks like it doesn't get registered. To-do list done, tests. Okay. Unfinished item marked. Does not mark the list to be done. And looks like the test passed. Okay. So this is all good. We're able to verify. Now there's one more test that we need to check, which is and this covers pretty much all the different variations that you could possibly add, which is, let's say that you have and there's 4 variations here. There's a non-empty done list and a non-empty not done list, where you add a done item to a not empty not done list, and an unfinished item into a already completed list. Now, some folks might argue if a list is already completed, there is no reason for you to go and add a particularly unfinished item. But that's not necessarily true when you use certain types of to-do applications where specifically you are trying to do, let's say, a backlog style, like, item completion list, which means you might add to the currently quote-unquote finished list something from your consistently infinitely unfinished list. So you're like done with items, you need more work, you'll just grab something from your backlog and stick it into here. So in that case, you want to be able to also handle that case and make sure that if you add a unfinished item into an already completed list, the list becomes undone automatically. So let's try that case, okay? So we're going to go ahead and say in our testing, adding unfinished, and it looks like here, basically, these two tests can fall into their own test suite. So we're going to go ahead and do these test suite combinations here. Right? Okay. So def test unfinished item tests. Add that, adding unfinished item to already completed list marks the list as unfinished. Okay, so how do we set up our test? So we first create an item that is unfinished. That is completed. Okay, and for this, I'm going to go ahead and say here that, and done is true. And let's go ahead and create a to-do list, or instance, make to-do list with name test list. All right. So now this guy is going to have in its items the list of item. Right? So far, so good. Now, we need to first check to see, again, that our items list is not empty. Okay? Oops. Is not empty. Next, we need to make sure that initially our list is completed. Okay? Now, what we're going to do is we're going to add a new item into the list. We don't care what it is. Let's say, in fact, let me call this finished. Sorry, let me do this. Finished. Okay, and unfinished. Make task. Finished task. Okay. Unfinished task. Right. So now what we'll do is we're going to go ahead and add push. Not push new, push, because push new is going to create a new list. You don't want to accidentally use push new into our items. Okay. So now let's go and make sure that we're no longer finished. Okay, we just covered all of our bases here. Okay. And we're gonna also do one more test with finished items. Okay. Okay. So far, let's run just this test suite. and see we have an issue. What is this issue? Cannot be set f items. Got it. My apologies. Here, this needs to be cells cn. All right, so to-do list is to-do list is finished. Okay, so it started with the items being unfinished. Okay, so this one right here, make to-do list, it's a problem with my constructor. So let's go back and double check our constructor. Okay. Alright, so let's go back to 3. Let's go and look at the constructor and see. Okay. Okay, so let's see what this is. What's being actually assigned to this, because items in should have been okay. Let me do something. Print items. Okay. Grab from here our here. You see what happens when this happens. Debug finished is unbound. Oh, right. Okay, got it. Right. Okay, so let me just do this. That parameter finished. Make task. Cells reset. This happens occasionally. Make list. Okay. So we now have an item. And what is items on our to-do list? It says that it's a task. So it may as well have been a screwed up cells thing here. So let's try our cells reset, and then let's go ahead and run our actual test suite, and it looks like our test is completed. So the problem was with cells. So from our coding excursion today, we could see that with cells, a lot of times you could get into an inconsistent state while developing, right? This is one of the pains that I was going to bring up with the limitations of this while I was playing around with this library. And that is, occasionally it'll go into this inconsistent state that the two options you have is either restart your Lisp image, which you don't need to do all the time, or do what's suggested, which is always start with lists before you start any new cells experiment in the running list image. Do what we just did earlier, which is run cells reset, which will reset the entire cells infrastructure and allow it to re-register all the types that are available for cells, because constant moving of the conditions screws up the signaling system behind the scenes. Now, to finish this guy off, there's two more tests that we need to quickly write, and then we've completed our model checking almost to actually verify that the model will actually do what it's supposed to do. And this is really related to finished items. Okay? One test is if we adding a finished item to a completed list keeps the list completed. Okay, and testing adding a finished item to an unfinished list keeps it unfinished. Okay, and these are all variations. As you can see, this one right here we've already tested, because this is just a repeat of this guy, except we're starting with the other way around. And that logically should tell you, okay, you should be okay, you don't have to worry about that. We can actually take this test verbatim if we wanted it, and literally hack it. By simply changing this to unfinished, this to finished, check first that we're not done, and making sure that we're not done. Okay, so that's the more obvious case. This one is really, if we take this, if you take this list here and paste it, okay, and although this is technically an unnecessary thing to do, you could certainly make it so that you add the list twice, okay, and simply change this guy to initially make sure that it's done, and it's always done. Let's run this very quickly. Okay, again, start with a clean state, run your tests, and see that there's an error. What is this error now? Finished item test. Oh, the error is that I labeled this wrong. Okay, and you can see that everything's done. So this, I hope, gives you guys kind of an idea on how you might end up leveraging this and creating, a very quick example of your test. Now, once you have this model all in place, you can use this like any other class object. Okay, you can actually create a GUI application that just triggers right appropriate callbacks that once the model gets checked, it hooks into your UI framework's event mechanism that can go and query the model to get the latest results. But that kind of integration depends on which UI framework you're using, whether it be QTools or LTK, or if you decide to actually make this into a web service that requires you to do something a little bit more complex related to, like, maybe using, say, WebSockets or something like that, or SSE to actually push notifications into the UI to go and give it the latest results, kind of like in a reactive manner. But the sky's the limit when you're designing some of this stuff. One thing to note is when you are when you're using this library is again, to reiterate, cells is very class centric. Cells requires you to develop your models using class. Now we've actually encountered one alternative to this library, and it's actually can be built to do flow-based programming, but it can also be used in this context to create a reactive style flow, and that is the cl-flow library. I have linked already Pavel's very nice, very detailed talk on cl-flow that we covered a couple of months ago, actually, on this, and I encourage you all to look at it. I've also provided, for folks who are watching this, links to his GitHub repository to actually go in and look at examples from that. I'm not going to cover cl-flow in today's discussion, just basically because we've already covered it. The stream is available. You can go back and look at that stream. If you have particular questions or particular ideas on or requests on how I might, further the discussion on cl-flow, please let me know, and we could certainly schedule something in addition to what Pavel already sent us. That's Borodust, who wrote the actual library. An additional library, which I just encountered before I started the stream, is cl-reactive. And cl-reactive is an alternative to using cells, to actually doing reactive programming, that I started playing around with, but given the time, I feel like it might be necessary to postpone this to next week. So with that, I thank everybody who stayed on for the live coding session. I hope you guys think that this is a good idea. Please provide feedback in the YouTube comments. Any suggestions for talk topics or stuff, please let me know. We will schedule it accordingly. And until next time, I bid you guys farewell and hope you guys have a good rest of your day. Thanks. Bye.